Hello, welcome back to our lecture series for Western Civilization 102. Our previous lecture, you heard from Mr. Elliott discussing the glorious revolution to the Treaty of Utrecht, basically what was happening in Europe during the reign of that great French king Louis XIV. Obviously, you heard quite a lot about warfare, even though it wasn't religiously based, as we've seen in previous lectures. Quite a lot of warfare was occurring in the 17th century. Dr. Robinson actually called it a general crisis because of all the fighting that had been taking place. Well, we're going to switch gears a little bit with this lecture, and we're going to discuss the first scientific revolution. Before you, of course, learn more about the different figures that will make up this scientific revolution and what they discovered and what European society will be learning, a little bit about the background to the prior to the 17th century and this first scientific revolution. You know, traditional views of astronomy, you may have heard of the geocentric theory. Geocentric, of course, meaning the Earth was at the center of the universe. Now, we learned this in probably elementary school. We know the Earth is not the center of the universe, okay? But that's what people believed prior to this scientific revolution. And we see with the scientific revolution that there are people that will challenge these ideas, these traditional views of not only astronomy but medicine, mathematics, you name it. And they will question it and come up with different theories, of course. So prior to the 17th century, prior to the first scientific revolution, people believed that the Earth was the center of the universe, geocentric theory. Because, I mean, obviously the sun, if you look into the sky, which is not good for your eyes, but if you look at the sky, you see the sun traveling, of course, moving across the sky, and you yourself feel like you're not moving. Well, of course you would think that everything moves around you, okay? Obviously we know better now. As far as medicine went, a lot of people believe that the body was made up of what's called 4 humors, H-U-M-O-R-S, humors. Not very appetizing humors, by the way. Black bile, yellow bile, blood, and phlegm. People felt that your body was made up of these 4 humors: black bile, yellow bile, blood, and phlegm. And when these humors were out of balance, that means you were sick. And so you would do, you know, different things to make sure they went back into a balanced state. Popular method would be bleeding. I know you may have heard of this in other classes. Or just even on TV, different shows. Leeches were commonly used, even up until the time of George Washington in American history, to kind of relate it. George Washington, our president, American history, had a really bad cold one time, and they bled him. They put leeches on him. Now, actually, leeches are used in medicine today to help with infections, skin infections and such. So they do use them in certain areas, but not to bleed the patient to where they balance the humors, as they felt that was the case. There were other methods. Purging was one method that was used as well. Not exactly going to help a very sick person get well. So medicine, we're going to see advances in medicine and people realizing you know, what's happening within the body to cause people to be sick or ill, and you'll hear more about that as well. Technology will come into play with this first scientific revolution. You may have heard of the telescope and Galileo looking at the heavens and looking at the mountains of the moons of Jupiter. Galileo, of course, being one of the important figures here during this scientific revolution. And of course, math, different aspects of mathematics with navigation and just the basic nature of things will be studied and pondered during the first scientific revolution. hear about men such as Copernicus and his heliocentric theory, stating that the earth orbits around the sun, that we are not the center of everything, okay? We're just part of the whole orbiting of the earth. Of course, this is going to lead to questions of how do the planets orbit? Is it a circular motion? Is it elliptical? What keeps the planets from not simply just moving out into space? You know, we know these answers. We know these answers today, but you know, back during the scientific revolution, these men are having to come up with theories on this, okay? So we'll hear about, you'll probably hear about Kepler, very famous German astronomer, and he agreed with Copernicus, but he will advance Copernicus's theory, talking about the planets and the attraction of the planets to the sun. Galileo, I mentioned him, obviously very famous, even looks at the spots on the sun as well. Galileo obviously has problems with the church, because just to let you know that the church isn't very open-minded about these new discoveries and these new scientific advances. And some of these people, especially I'm thinking Galileo, will have to defend themselves, go to trial. And Galileo, although he's not executed, he is placed under house arrest by the church because of his ideas on science. Oh, Sir Isaac Newton. No, you have had to have heard of Sir Isaac Newton. He was an Englishman. Interesting fellow, Sir Isaac Newton. Discovered calculus. Aren't we happy about him? Don't we love Sir Isaac Newton? Discovered calculus in a few weeks. Ugh. It takes most of us quite a while to grasp calculus, but it can be done. The laws of universal gravitation, gravity. Every object continues in a state of rest in a straight line unless deflected by a force. For every action, there is always an equal and opposite reaction. All these come to mind from maybe some of your science classes as well. Medicine during the scientific revolution. Like I said, people are starting to find out more about the body, the human body, and how it functions during this first scientific revolution. We also have people like Descartes. You may have heard of Descartes. He's famous for I think, therefore I am. And he will come up with a rational approach to the scientific method, a deductive method. You may hear about him as well. So quite a lot of figures during this scientific revolution. Very interesting to see how it will affect later societies, because here with this scientific revolution, we will see the roots of what we'll study in our next lecture, which is the Enlightenment. So let's find out a little bit more about the first scientific revolution.
The Renaissance, the Reformation, and the Age of Discovery all dramatically changed the way that early modern men and women thought about the world. The first scientific revolution changed the way that they thought about the universe as a whole. The first scientific revolution really began in the 16th century, but it reached its peak in the 17th. Before we talk about it, however, it's necessary to look at what people believed about the universe before the first scientific revolution in order to measure the full impact that the changes of the scientific revolution brought about. Therefore, we'll at first take a look at the late medieval synthesis in looking at the universe, and then we'll break that down as new scientists come on the scene. The late medieval synthesis that made up the way that people looked at the universe consisted of a number of elements. There was Aristotelian physics, Ptolemaic astronomy, Hippocratic physiology, Galenic medicine, the hierarchical principle, the great chain of being, alchemy and astrology, magic and witchcraft, Christian theology, and what I like to call apparent common sense. Let's look at those individually. In Aristotelian physics, that is, physics as explained by the ancient Greek philosopher Aristotle, who was also a scientist, there were a number of features which, in fact, are wrong, but which had enormous consequences for the way that people looked at the world and the universe in the Middle Ages. In terms of motion, Aristotle believed that the natural tendency of matter is to be at rest. He also believed that the heaviest bodies in the universe naturally tend to fall toward the center of the universe. The Earth itself is, of course, solid and heavy, and by the terms of Aristotle's view of things, it was indeed the heaviest object in the universe. The reason for this is that Aristotle believed in what we call a geocentric universe, that is, an Earth-centered universe in which the Earth is literally at the center and everything else revolves around the Earth. That, of course, as we know today, is wrong. And in fact, even in Aristotle's own day, there had been people who knew it was wrong, like the philosopher Aristophanes, who argued instead for something called heliocentrism, where the Earth orbits the sun. But Aristophanes was rejected, like hundreds of others who came after him, because who was he to contradict the great Aristotle? Now, let's add to Aristotelian physics Ptolemaic astronomy. Ptolemy was an ancient 2nd century AD thinker who also believed in a geocentric universe, but who added some additional elements. He believed that the Earth is surrounded by a number of concentric crystalline spheres, or if you want to think of it that way, giant glass balls of increasing size, into which all of the celestial objects, the sun, the moon, the planets, the stars, are set. And according to Ptolemy, these spheres circle around the Earth, and that is what gives us the appearance of the sun, the moon, the stars, and the planets moving across the sky. In addition to that, he believed that outside of this set of concentric spheres, there was one final sphere known as the primum mobile, or first mover, which kept all the rest in motion. And presumably, what kept it in motion was God. Another aspect of Ptolemaic astronomy is that Ptolemy taught that the farther out you go from Earth, the more pure the objects there are. So there is an ascending order of purity from the Earth at the center, working our way out to greater and greater purity. This is a hierarchical principle, the notion of hierarchy of purity from lowest at the Earth to highest at the extreme. Added to that, there is also medieval theology. In medieval theology, the characteristic of heaviness was associated with corruption. Not corruption like political corruption or financial corruption, but with actual decay, physical decay or rot. And it stands to reason that if we put all this together, if the Earth is at the center of the universe, if that makes it the heaviest object in the universe, then it is also the most rotten object in the universe. And indeed, that's pretty much what medieval theology taught, that the Earth is a place sunk in sin and corruption, sort of the cesspool of the universe. And think about traditional views in the Middle Ages of where hell and heaven are located. Hell is thought to be at the center of the earth. Heaven is thought to be as far away from that as you can get. It fits into that hierarchical principle of greatly increasing purity from the corruption of earth with hell at its center to the purest of heaven out at the extreme. Now, the geocentric model makes a certain amount of sense in terms of its internal logic. In other words, it all works. This is not actually how the universe is organized. We no longer think in religious terms of a hell literally located at the center of the earth or a heaven literally out there as far as you can go, but it has a certain amount of internal consistency, so it makes a good deal of sense. In addition to that, there are other elements that we can add. One of these is what I like to call apparent common sense. That is what looks like common sense, but may turn out to be deceptive. For example, celestial objects like the sun and the moon and the planets and the stars all seem to orbit the earth. If you stand outside in a parking lot all night, it does in fact look as though all those objects move across the sky. We know now that that's caused by the turning of the earth, but apparent common sense might tell you otherwise. In addition, if you live anywhere near a volcanic region or a place where there are geysers, it might indeed seem that something very hot is at the earth's core, because something very hot is, and that something might be hell. And if hell is at the center, then heaven logically would be as far away from that as you can get. So internally, this is a system that is very strong, even if it is scientifically in error. Another aspect of the medieval view of things has to do with what's called the great chain of being. Now, you know, if you take a science class now, a biology class or a chemistry class or what have you, that scientists classify things. They put them into what we call taxonomies, so that, for example, you talk of life in terms of species and genus and family and order and what have you. We talk of chemicals in terms of the types of atoms and molecules that make them up. Well, there was a different sort of taxonomy for science or what passed for science in the Middle Ages. And this is based on the notion that every single thing in the universe forms a part of what's called the great chain of being, ranging from the lowliest inanimate object at the bottom to God at the very highest. Furthermore, it was believed that everything has its proper place in the great chain of being, and that to get out of your place is to violate the will of God. This is one reason why in the Middle Ages rebellion was considered to be such a horrifying offense. For a person to rebel, to try to rise above his normal social standing, was, in this way of thinking, to violate the will of God. Now, the hierarchical principle comes into this in a very big way. So let's look at how this works out. If we start at the lowest level of the great chain of being, we start with inanimate objects, rocks, minerals, and what have you. Now, if you think in those terms, even today, we tend to see inanimate objects in a hierarchy. If, for example, you're a guy and you show up at your girlfriend's door on Valentine's Day with something made of gold, you'll probably get a better reception than if you show up with something made of tin. Why is that? We have this hierarchy of values that says that gold is worth more than tin, even though both of them are very useful metals in their own right. That goes back to this notion that there is a chain of being in which gold is a more pure metal than tin or copper or what have you. Now, of course, inanimate objects are things that have no life, no sensation, and no intelligence. That's why they're at the bottom of the whole chain. Next up from that, we have plant life. And plant life, of course, does have life, but no sensation, at least not as the Middle Ages saw it, and no intelligence. Plants, too, are arranged in a hierarchy of purity. Again, to use my previous example, if you show up on Valentine's Day with roses, you'll get a better reception than with daisies. Both make me sneeze, they probably do the same thing to you, but the fact is, somewhere along the line, the rose came to be seen as a more pure flower than the daisy or some others. We do the same things with other forms of plant life. We talk about the noble oak. Nobody ever talks about the noble sycamore tree. So all of these things are in a hierarchy of value as well. When we move to animal life, to animals have life, they have sensation, and at least according to the Middle Ages, they don't have intelligence, although anybody who's ever owned a pet knows better than that. Nonetheless, animals come in a hierarchy as well. They are seen as having different value. That is why the lion is the king of the jungle. The possum never gets to be the king of anything. Then, of course, there come humans, and we already know that humans are arranged in a hierarchy in the Middle Ages, ranging from serfs at the bottom of society to kings and emperors and popes at the top, and everybody has his appropriate place. Now, next up from man, who has life, sensation, and intelligence, come the angels, who have life, sensation, intelligence, and are without sin, and who do not die. They too are arranged in a hierarchy. They're believed to be 9 different categories of angels, and paralleling them in hell, 9 different categories of fallen angels or demons. And of course, at the top of the hierarchy is God. Now, modern science doesn't operate this way. Modern science categorizes life and objects and what have you in a different way from this. But again, this has an internal consistency that fits very well with the other things we've been talking about, and that's hard to break down initially. Mankind, of course, has long been broken down in that way, and it is simply applied to everything else as well. Now, if we turn to human physiology was based in the Middle Ages on the teachings of the ancient medical practitioner Galen, who was the be-all and end-all authority. And what Galen taught, based on the teachings of the still earlier Greek thinker Hippocrates, was that the human body is made up of 4 substances called humors, each of which has certain characteristics associated with it, and an imbalance of which will cause you to become ill. Hippocratic or Galenic physiology taught that the humors are transmitted through the veins from the liver to the heart. And if they get out of balance, then you're in trouble. Well, what are they? The 4 humors are blood, phlegm, what's called yellow bile or melancholy, and black bile or choler. And the thinking is, if these are in balance, you're healthy. If they're out of balance, you're not. Now, another factor that can affect your health, and we'll look at some of the implications of this in just a minute, is the elements. The elements as they existed in the Middle Ages were not the elements you encounter on a periodic chart in your chemistry class these days. They were 4 things that in fact aren't elements at all: earth, water, air, and fire. And again, these appear in a hierarchy of ascending purity. Where do you find earth? Well, usually under your feet. Earth is not particularly pure. If you get earth on your hands, you wash it off before you eat. What do you wash it off with? Water, which is considered to be more pure than earth and is found higher, farther from hell, closer to heaven than earth is. Above the water, you find the air, which at least in the Middle Ages was more pure, maybe not now. And finally, the most noble of the elements was thought to be fire, and where one normally finds fire is in the air. So the elements, the humors, both are believed to impact upon your health. There's some other factors that fit into this as well. There are the related properties of coldness, which is associated with earth, wetness, which not surprisingly is associated with water, hotness or heat, which is associated with air, and dryness, which is associated with fire. And all these things are believed to interact to affect your mental and physical health, possibly also influenced by the stars and the planets and the sun and the moon. Now, suppose that this is the case. Well, Galenic medicine based on the teachings of Galen, argues that if you are ill, it is probably because of an imbalance in your humors that is affected to some extent by these other elements like heat and cold, dry and wet, and so on. So, what do you do? Well, suppose you cut somebody open, and don't try this at home, this is a hypothetical point. What do you see the most of first? Blood. So the assumption made by medieval medical practice is that if your humors are out of balance, you probably have too much blood. And the cure for that is to get rid of some of it. This can be accomplished in one of two peaceful ways. One is to have a physician cut you so that you bleed for a while. Of course, you have to be careful with this or the cure becomes worse than the disease. The other method is to use leeches. Either way, the idea is if you remove some of the blood, it will make you well. Now, this also has a kind of self-fulfilling internal logic about it. If you bleed someone, it will probably make that person feel a little lightheaded, which may actually feel good for a short time. The other thing is this. Suppose you bleed someone and he gets better. Well, that proves it works, right? Suppose you bleed someone and he doesn't get better. What's the answer? You didn't get to him in time. Basically the same answer you get from the medical community today. Now, besides bleeding, there is another approach that is taken to restoring the balance of various factors in human health. If you've ever had a cold, and I know you all have, you know that one of the things associated with a cold is moisture, a runny nose, sweating, and all of that sort of stuff. So in the Middle Ages, apparent common sense said that if you're ill, you probably have too much moisture, too much of that wet element that we associate with water. Well, what to do about that? There is also a treatment for that called cupping. And I most assuredly do not recommend this to anybody, but the way this worked is it was designed to get moisture out of your body. So what a physician or a practitioner would do is take cups and heat them up and then place them on the bare skin of the patient. Now this, of course, burns. It creates a blister. Now, if you open up a blister, what do you find inside of it? Moisture, right? So apparently what cupping is doing is it's drawing excess moisture out of the body, which supposedly will make you better. If you get better, proves it worked, right? If you don't get better, then didn't get to you in time. So both bloodletting and cupping were regular features of medical practice. It's a wonder in a way that anybody survived this. Another important feature in the treatment of physical illness in this period came from those people who are known as apothecaries, who were the medieval equivalent of pharmacists. Apothecaries actually did produce some medications that had some utility, medications made from herbs and from various plants and roots and what have you. Now, they weren't as prolific as the millions of herbs that you can buy today, many of which have little practical utility, but some of them actually did serve a real medical purpose. But alongside that, apothecaries also manufactured an awful lot of medicine that really had very little to do with dealing with either symptoms or cause of disease. A lot of the medicine made towards the end of the Middle Ages consisted very largely of spices, which were expensive, and wine. So a big part of the medicine you might take for something would be spices and wine, which meant that it tasted pretty good and it probably made you feel better for a while. If you got better, that meant it worked. If you didn't, it just didn't get to you in time. But the main application of that was not really all that beneficial, except to the pocketbooks of those who imported wine and spices at the time. Another interesting feature of medical practice in the Middle Ages is that physicians, those people who went to a university and earned a degree in medicine, did not actually do much in the way of practice. They did no hands-on work at all. In fact, in medical school, if you want to call it that for this time, they learned very little about human anatomy and physiology, very little about pharmacology. What they learned was a fairly standard curriculum where they learned how to debate, where they learned the art of rhetoric, where they learned grammar and what have you, but little practical medicine. Much of the actual practical medicine was carried out by individuals known as barber surgeons. Surgery was not done by physicians. They didn't get their hands dirty. Surgery was done by barber surgeons, who often got a lot of their experience on the battlefield, where limbs had to be amputated or wounds had to be sewed up or bones had to be set. One of the reasons why a barber pole, even today, has red on it is from the blood associated with the barber surgeon's practice. Now, we don't typically think of barbers as surgeons. But remember, the Middle Ages has a different set of taxonomies than we do, and they do have a certain logic, even if they don't make any sense in terms of modern science. Think about what a barber does. A barber performs an amputation. He amputates part of your hair. So in the eyes of medieval people, removing part of your hair or removing an injured finger didn't seem all that terribly different. In fact, when it came to performing simple surgery and healing wounds, barber surgeons were much better at it than physicians, but they were held in rather low esteem because they were mere craftsmen, whereas physicians were considered to be more educated. A couple of the things that barber surgeons had to guide them in what they do are a couple of fairly grotesque images that survive from the later Middle Ages. One of these is a diagram showing you various places that you could do bloodletting on somebody to cure different sorts of problems. Another is a figure called the Wound Man, which shows some poor imaginary guy with virtually every wound you can imagine, knives and arrows and what have you sticking out of him all over, and these were used as guides for showing barber surgeons how to function. Now, if we move from medicine and biology to chemistry, what we discover is that there is no chemistry, properly speaking, in the Middle Ages, with the exception of metallurgy. Humans had been making things out of metals for thousands of years by the time we get to the late Middle Ages. But more proper chemistry really grew out of a pseudoscience known as alchemy. Almost everyone has heard of alchemy, but very few people know the full range of what it covers. What most people know about alchemy is that one of its goals was to transmute simple metals or unvaluable metals into precious metals. Most famously, alchemists were looking for a formula to transform lead, of which there's a lot, into gold, which is rare and very valuable. And of course, if anybody really knew how to do that, we probably all would be doing it. But this is not the only thing that alchemists did. Alchemists had a whole theory of alchemy, which involved the transmutation of various things, not just lead to gold, but other things as well. And one of the things that they were interested in doing was trying to prolong human life by the transmutation of life, if you will. One of the things they sought to do was to create what they called aqua vita, or the water of life. And they did this by an increasingly sophisticated process of distillation. Now, they didn't produce anything in this way that made people live longer or live forever. What they did sort of accidentally produce was vodka and whiskey and rum and so on. Any distilled liquor that could be made using the same distillation process that alchemists invented trying to produce the water of life, or aqua vita. Moreover, modern chemistry still uses the distillation process for all sorts of things. So we have a pseudoscience, alchemy, creating a lot of the equipment that is later used by a real science, chemistry, down the road. And of course, as anybody who is a fan of Harry Potter knows, one of the things that alchemists did was to look for something called the Philosopher's Stone. This is not an idea that J.K. Rowling invented. It's an idea that's been around for thousands of years. And the idea was that the philosopher's stone, if it could be created or found, would give you immortality. It would allow you to live forever. And so one of the things that alchemists try to do with their experiments with distillation and transmutation and what have you is to create that. They did not succeed, but again, in the process, they discovered a lot of things sort of by accident and created a lot of equipment for other purposes that real science uses later on. By the way, there was an alchemist named Nicholas Flamel. He was a real person. That does not mean that Dumbledore was a real person, but he was a real late medieval alchemist and astrologer who spent a great deal of time trying to find the philosopher's stone. That brings us, as a matter of fact, to the whole study of astrology. Now, astrology is a system of thought predicated on the notion that human life is impacted by the movements of the stars, the planets, the sun, the moon, the placement of the constellations, and what have you. So that, for example, it's important when you are born, where the sun and the moon are in relation to the constellations, whether there is a comet in the sky, whether there are meteor showers, whether there is a nova that is visible in the sky. All of these things are believed to predict things about your life. Now, astrology has largely been reduced in modern times to, the columns that you find in the back of the newspaper somewhere that will give you your horoscope, tell you that you're going to meet somebody tall, dark, and handsome and inherit a lot of money, which I'm still waiting to happen in my case. But astrology, even though it's not real science, even though it is a pseudoscience, was an extraordinarily sophisticated system that sought to relate all the different movements of heavenly bodies to human affairs, to human health, and what have you. It associated different planets with different elements or different metals. It associated different constellations with different temperaments, even as the modern day horoscope still does. It did a whole lot more than provide simply a pickup line like, what's your sign? It was a very, very sophisticated system. And indeed, many of the early scientists of the first scientific revolution were also practitioners of astrology. We have left astrology behind as a science, but it was thought of one at the time. And although it was not a true science, it did, as a matter of fact, give rise to an awful lot of observation of the heavens and the recording of a great deal of data, which has become the basis for the science of astronomy much more recently. Now, there are a number of figures early on in the history of science who begin to change some of this, but who also exemplify the fact that with the scientific revolution, as with so many things, people often have one foot in the future and one foot in the past. For example, there was a medical practitioner by the name of Paracelsus who lived in the early 16th century, who used minerals for healing in a way that we still do today, who opposed Galen's and Hippocrates' ideas about the humors, but who in many respects still believed in astrology, still believed in magic, and what have you. Another of the important early figures, although not much of one when it comes to advancing science, was Girolamo Cardenio, a kind of systematizer of astrology, who didn't deliberately do what we think of as astronomy, but who nonetheless produced a great deal of information that astronomers use. One of his contemporaries was the Englishman John Dee, who has featured in a number of the movies made in recent years about Queen Elizabeth. He was, in fact, Queen Elizabeth's magician and her astrologer. She believed firmly in both things. But he also was a great source of policy making. He was one of the leading naval policy makers at her court, and he, in fact, owned the largest library in the world at the peak of his influence. Indeed, his library is the basis for the modern-day British Library. And Dee is a good example of somebody who still practiced astrology, still believed in magic, but also was making steps forward in other ways. Now, before we look at some more profoundly influential scientific theoreticians who really do begin to move us into new territory, there's a couple of other elements that we need to add. One of these is the widespread belief in the late Middle Ages in witches. It's a mistake that a lot of people make to assume that the witch craze lasted all through the Middle Ages. That, in fact, is not true. There were occasional concerns about witchcraft in the Middle Ages, the odd person here and there arrested and charged with practicing witchcraft, but the real witch craze occurred primarily between about 1450 and about 1650, over a period of about 200 years. And it actually owes something to the Renaissance. As the Renaissance discovered a great deal about the ancient world, one of the things that it discovered was ancient philosophical treatises that attempted to explain the belief in witchcraft in a quote-unquote scientific way. And again, if we no longer believe in witches except as something interesting to dress up as on Halloween, there was nonetheless a very systematic body of quote-unquote knowledge about witches at the end of the Middle Ages. For example, in most cases, particularly on the European continent, witchcraft was associated with what we called diabolism. That is, the idea that the witch had made a deal with the devil in order to get access to supernatural power. There was a belief in what's called the maleficium. That is, a witch who had the maleficium had the ability to do evil things to other people. It was thought that various animals were familiars, that is, that they transmitted information back and forth between witches and the devil, the most common, of course, being black cats, black dogs, or black goats, although other things were believed to be familiars as well. And there was even a belief in something called the devil's mark, which was thought to be something that looked sort of like a wart or a mole or a nipple that a devil's familiar might come and suck blood from as a way of nourishing evil power. This, in fact, was thought to be extraordinarily cold, and if you'll pardon the slight profanity here, this is where we get the modern expression cold as a witch's tit. This didn't refer to an actual breast, but to a growth that was thought to be a place where a familiar came and sucked blood. In the late Middle Ages, everybody also believed in magic. I don't mean magic in the sense of pulling a rabbit out of a hat, but magic in the terms of the ability to harness supernatural power for human purposes. This could take all sorts of forms. It might be magical spells, it might be magical formulas, it might involve going through some sort of ritual, but all were believed to bring about the application of supernatural power. Now here's the thing. Almost every early scientist was also a magician. Science is something that people stumbled on in a lot of ways, trying to do magic, trying to prevent witchcraft, trying to perform alchemy, and what have you. If you think about it, if you took most of the technology that we have today and showed it to somebody from the later Middle Ages, what would it look like to them? Magic. And so science grows out of this, and as time goes on, scientific explanations replace the old superstitious or supernatural explanations as time goes on. Now, of course, the Renaissance feeds into this with the recovery of ancient science and by the breakdown of people's tendency to think only in terms of the way things always have been. The Age of Discovery does that as well by opening up European access to Far Eastern cultures and the New World. One of the biggest factors in bringing on the scientific revolution is, in fact, the Reformation. Because after the Reformation, there is no longer a single church. There is no longer a single theological truth. There are state churches in the various countries of Europe. And by and large, in the early days of the scientific revolution, scientists tended to make more headway in Protestant states than they did in Catholic states. There's a good reason for that. It's not that Catholics were any more anti-scientific than Protestants, but Catholics were invested in the old view. The Catholic Church had been around for hundreds of years. It had incorporated all the old view into its teaching, and the Catholic Church had been attacked by the Renaissance, by the Reformation. It's feeling a little sensitive and therefore more resistant to science than Protestant states, which had a relatively new faith and very little invested in the past. Nevertheless, the first person usually recognized as a founding father of the first scientific revolution was in fact a Polish Roman Catholic priest by the name of Nicholas Copernicus, who lived in the late 15th and early 16th centuries. Besides being a priest, Copernicus had a hobby that became kind of an obsession with him, and that was observing the movements of the various celestial objects. And over time, he began to accumulate enough information to begin formulating an alternate theory to explain the movements of heavenly bodies. He came up with what Aristophanes had come up with a couple of millennia earlier, the heliocentric theory, the idea that the Earth orbits the Sun rather than the other way around, and that what creates the appearance of the Earth being at the center of the universe is the fact that it turns on its axis. He explained this in a book called On the Revolutions of the Celestial Spheres, which was published in the year of his death, 1543. It, of course, was greeted with skepticism by many people since it seemed to contradict apparent common sense, and also because it went against the teachings of his own church. But it did begin to trickle out to other thinkers and to influence the thinking of many people. Of course, this is often, the whole first scientific revolution is often a step forward, a step back, or a step forward and two steps back, so it doesn't flow smoothly. The next major figure I want to mention is a Dane, a Danish nobleman by the name of Tycho Brahe, who lived in the second half of the 16th century, and who really took astronomy about as far as you can go with the naked eye. He became very obsessed with the stars and the planets and what have you, partly because of an interest in astrology, but partly because of a dawning realization that there was more to this than just old astrological superstition. He was credited with discovering a nova in 1572, a new star, as it was called, and that gained him a great deal of fame. Subsequently, he set up on a little island called Uraniborg off the Danish coast a kind of observatory that was funded by the king, Frederick II. And there he and his assistants managed to record an extraordinary amount of information about the movements of celestial bodies. Pretty much everything you could see with the naked eye. Later on, he became the imperial astronomer to Emperor Rudolf II, one of the more eccentric figures of the early modern period. But for all the knowledge that he acquired, Tycho Brahe continued to cling to the old geocentric system. What was needed was somebody to take Copernicus's new system and Tycho Brahe's data and put them together. And that person turned out to be a German Lutheran astronomer by the name of Johannes Kepler, who was at one point an assistant to Tycho Brahe, and who also was a mathematician, and who also, interestingly enough, practiced astrology. He succeeded Tycho Brahe as the astronomer of the Holy Roman Emperor Rudolf II, and he went on to accomplish some pretty substantial things. Now just to show you that we're in a period of real transition here, while Johannes Kepler was doing all of this, his mother actually was being prosecuted as a suspected witch. She got off, but the fact that one of the great figures of the scientific revolution could have a mother being prosecuted as a witch tells you that we're in a very transitional phase. Kepler did a fair amount of work with what we nowadays call inertia, but the most important thing he did was to come up with something called the laws of planetary motion. Assuming that Copernicus was right, that the planets and the Earth all circled or all orbited the sun, he began to work out a mathematical formula that described those movements. And what he discovered is that of the known planets, and at this time it was a couple of the planets, Neptune and Pluto, were unknown because you can't see them with the naked eye. The known planets all had orbits that could be described by the same mathematical formula. And this is a big thing, not just for astronomers, but for the whole scientific revolution, because what it suggests is that there is such a thing as scientific law. Here is a law that explains the movement of all planets, that makes the movement of planets understandable, and it begins to suggest that perhaps there are other laws that can be discovered as well. One of Kepler's contemporaries, he did most of his work in the early 17th century, was an Italian Catholic astronomer by the name of Galileo Galilei, or usually just known as Galileo. That's what happens when you're really famous. One of the things that he did was to develop an improved telescope, a telescope that was good enough to allow him to see the mountains on the moon, for example, which didn't look any more pure than the geology of the Earth. It allowed him to see that the planet Venus has phases, which doesn't fit into the old geocentric theory. Perhaps most shockingly, he discovered that Jupiter has moons and that Saturn has rings. And that brings up a very basic problem. If the planets are set in concentric spheres, how do the moons get through them? This got Galileo in a lot of trouble. He published the results of his findings and was heavily criticized by the church. Some of his opponents suggested that the telescope was an instrument of the devil and that he was being misled thereby. But he stuck to his guns. Another thing that he worked on was falling bodies. And he discovered the law of falling bodies, which is that any body, no matter its weight, its mass, or whatever, will reach a maximum speed if it falls. Indeed, he came very close to discovering the law of gravity, although not quite. He also did work on inertia. He also studied the moon's effect on the tides. He was a true scientific genius. And he got into a great deal of trouble. A lot of this trouble had more to do with Italian politics and Italian church politics than it did with an innate Catholic hostility to science, because let's remember that Galileo and most of his Italian supporters were Catholics too. But he antagonized the Jesuits, and that was never a good idea, and he spent the latter part of his life under house arrest, being watched very closely by the Inquisition. As I said earlier, Protestant countries could be safer places for scientists. England is a good example of that. There, Francis Bacon, an important man as a politician as well as a scientist, came up with what we call the inductive or empirical method of doing science, which is a method of science still very much used today that's based on repeated experiments or repeated observations that goes from looking at particular experiments or particular observations to drawing more general conclusions. On the flip side, over in the Netherlands, a French expatriate philosopher named René Descartes came up with what we called the deductive method. That is, one that starts with essentially just an idea and looks for evidence to back it up or to contradict it. He is associated with the famous phrase, cogito ergo sum, I think, therefore I am, which literally meant that he knew he existed because he was thinking, and then he works out from that rationally to other things. Another important figure in this period was the anatomist Andreas Vesalius, who began practicing dissection and discovered the function of internal organs that was important for contradicting Hippocrates and Galen. There was William Gilbert, the English scientist who discovered magnetism, a force that we're still pondering on today. William Harvey, an English scientist who discovered the circulation of the blood from the heart to the arteries to the veins, and therefore was the first person to really understand how that worked. The Dutchman Anton von Leeuwenhoek, who invented the first microscope and saw the first microorganisms, although he failed to really understand why they were significant. And Robert Boyle, an English alchemist who became, again, sort of accidentally, the first modern chemist, discovering, among other things, Boyle's law, which says that for a fixed amount of gas at a fixed temperature, pressure and volume are inversely proportional. In other words, if you heat up a closed container, the gas inside it will expand. He also discarded the whole notion of the four elements. But of course, the giant of the first scientific revolution, the man who is to the first scientific revolution what Albert Einstein is to the second scientific revolution, was Isaac Newton. An English scientist who did all sorts of work. He is known, for example, for his work with optics, that is, studying the behavior of light using lenses and prisms. One of the things that's truly stunning about Newton is that he was working at Cambridge one summer doing work on optics and was forced to go home for a while because of an outbreak of the plague. He was having difficulty mathematically expressing what he was finding. So he took a few weeks off and essentially invented calculus. But more impressive is that over time, Newton began to pull together all of the discoveries of his predecessors and to discover a number of what he saw as universal laws. It was Newton that discovered the law of gravity. It was Newton who discovered various laws of motion, like, for example, that which says that for every action there is an equal and opposite reaction. And in 1687, he published his findings in a book called Principia that becomes one of the most influential pieces of work in the history of science. It revolutionized science because it led people who read it and understood it to begin to see the universe not as a disordered, mysterious place that could not be explained, but as a place that functioned according to unchanging, inflexible natural laws that could be understood once they were discovered. Even Newton, of course, was a man who had a foot in the past as well as a foot in the future. He was an alchemist along with everything else. And he became obsessed later in life with trying to date every single event in the Bible, which is a fundamentally impossible task. Now, during Newton's lifetime in Britain, something occurred which showed that science had ceased to be something suspect, something bordering on heresy, something that you could be prosecuted for, to something quite acceptable. And that was the foundation in Britain in 1662 of the Royal Society, the first scientific society that was founded by the king himself, Charles II. In fact, these royal societies, like the Royal Society, took a bigger role in the advancement of science than the universities, which at the time were somewhat backward. A similar one was founded in France in 1666 by Louis XIV's minister Colbert, and known as the Academy of Science. Well, finally, what this leaves us with is a couple of very profound notions at the end of the first scientific revolution. One is this notion of the universe as an orderly place, as a place with inflexible, unchanging laws, as almost a machine. And it begins to affect the way that people think about God as well. If God created the universe, and if the universe is this orderly place which has all of these laws, then God is the author of scientific law. And if God has ordained these scientific laws, then it stands to reason that He will not interfere with them. So a popular image by the beginning of the 18th century and one that we'll encounter again in discussions of the Enlightenment, is the idea of God as the great clockmaker. God who built the universe, which operates with all the efficiency and the regularity of a clock, who wound it up, so to speak, and who allows it to run. How do we know this? Well, the scientists of the first scientific revolution say we know it by the application of human reason. And that notion that the universe is an understandable place if you simply apply human reason will become the basis for the Enlightenment of the 18th century.
All right, very interesting, first scientific revolution. All right, well that actually sets us up for our next lecture, the Enlightenment, also known as the Age of Reason. Just think reason. You can't have reason if you don't have a scientific way of explaining things in the universe. You know, it all goes hand in hand. So the scientific revolution of the 17th century, setting up, and some of the 18th, is setting up the Enlightenment of the 18th century, or the Age of Reason, where people are saying the universe can be understood, that it can be governed by natural, not supernatural resources. The Age of Reason uses this reason for politics and religion. The scientific method could answer all questions, and the human race could be educated and improved. Enlightenment. Until next time.